With Lasergene Genomics Suite, you can perform transcriptome assemblies on a desktop computer. In cases where you have a large dataset but limited RAM, you may wish to perform your assembly in multiple steps, using a combination of Denovo and templated assembly strategies. The first step is to create a pilot transcriptome assembly in SeqMan Engine. Choose Denovo assembly as your assembly type, then name your assembly and specify a project folder. For this first assembly, we'll use the SeqMan Pro format, which has a 10 million read limit. Next, choose your read technology, and then load your reads. In this case, I've loaded Illumina data as single-end. Loading the reads as unpaired or single-end minimizes the amount of RAM needed for the assembly. Next, I'm going to change the maximum total reads to 1 million. Again, this will minimize the amount of RAM needed for the assembly, but should still allow SeqMan Engine to assemble many of the transcripts in my project. On the Assembly Options page, I'm going to set minimum sequences to 500. This tells SeqMan Engine to remove contigs with less than 500 sequences. Click Next, and then click Assemble to begin the first assembly. Once the assembly is complete, open it in SeqMan Pro. Here you can see a list of all the assembled contigs. You can look at any of these contigs in detail by double-clicking to open the alignment view, or by looking at the strategy view to explore the depth of coverage. I'm going to sort these contigs by length, so that the longest contigs appear at the top of the list. At this point, you may want to blast some of the longer contigs. To do this, select one or more, and then go to Net Search, Blast Selection. Choose the desired blast database and click OK. You can then view your blast results directly in SeqMan Pro. Alternatively, you can export the consensus sequences and blast them in another program like Blast2Go. In this case, I want to export the consensus sequences for all of the contigs that are at least 1500 base pairs long. To do this, I'll select the first contig in my list, and then scroll down until I find the first contig that is 1500 base pairs. I'll then shift-click to select that. Then go to Config, Save Consensus, Single File. I'll then save my sequences as a single FASTA file. Now I'm going to launch SeqMan Engine again and create a second transcriptome assembly. This time I'll do a templated assembly using the exported consensus sequences as my template. Again, name the project and select a project folder. Then load the FASTA template sequence that we created in SeqMan Pro. And now load your reads again. With a templated assembly, we're not going to limit the number of reads that can go into the assembly. So any reads that map to the existing consensus sequences will be included. Any reads that don't map will be saved as unassembled sequences. We'll assemble those in a third step later. Click Next until you can click Assemble. The result of the second assembly is a BAM file, which can also be opened in SeqMan Pro. Here you can see we have contigs for each of the consensus sequences we exported from the first assembly, but now we have many more sequences within these contigs. The contigs we have here may represent the majority of transcripts in your project. However, any reads that did not map to the consensus sequences from our first assembly were saved out to a FASTQ file. As a third step, we can do a de novo assembly of those reads to capture any remaining transcripts. Using the unassembled reads as our input, we can then set up a de novo transcriptome assembly in SeqMan Engine, just as we did in the first step of this video. The result can be viewed in SeqMan Pro. From here, you can again blast the consensus sequences, or export them for further analysis. If you have any questions about transcriptome assemblies in Lasergene Genomics Suite, visit us at DNASTAR.com or contact us at support@DNASTAR.com.